Hi everyone, we are live with our OWASP Bangalore meet, and today we have a very interesting section around setting up the home lab with the VMware Fusion or Workstation. I'm sure it's going to help a lot of people, especially if I talk about myself. I had a lot of issues in the beginning when I was just kickstarting things on the virtualization platforms. So I am sure this session is really going to help all of us. So over to you, Victor. But
Yeah.
let me say something about you before I actually hand it over to you.
No problem. Thank you. Yeah, go for it.
So for everyone, if you don't know Victor, Victor is working with one of the multinational companies. Apart from that, he does a lot of pro bono work. He's part of a lot of initiatives at OWASP. He's also running a community which is called Virtually Testing Foundation, and which is actually helping a lot of communities around the world. That's one interesting aspect. And he's also on the board of CSA LA,
Yeah,
if
LA
I'm not
chapter.
wrong.
Yep.
Yeah. So these are just this some of the things that I'm speaking about, but he does a lot of pro bono work and help the people around. And I think a lot of times I also discuss community initiatives with him. So now
Yeah.
I will let him speak more and I'll speak less. Over to you,
Thank,
Victor.
thank you. Thanks so much. I'll go off camera so I can actually be comfortable and just talk about the slides. And also, you don't have to look at me. It's my morning face. So here we go. All right. Well, thank you, Vadna, for the warm welcome and the nice, kind words. Let's talk about today's topic: a home lab with the VMware Fusion or Workstation. Why are we here today? So this topic actually came up because from past, I would say 10 to 12 years, I have seen personally and also witnessed it multiple times where we want to start our career in cybersecurity. We want to make our first step, and the first step is usually how do I actually penetrate a lab, or how do I learn a red team exercise? How do I actually detonate a malware? And no one, any organization will allow that in the production network. So what do we do? It used to be you buy a couple of laptops or you make a couple of PCs at home, and then you figure out a way to simulate a server, a victim, a hacker, or maybe an internet. So it used to be that way. Thanks to virtualization, now you could do all of that within same PC or laptop, given obviously the laptop or PC is powerful enough to run a virtualization. So today we will talk about, and the talk would be focused on VMware Fusion or Workstation, how to use it for multiple projects that you have. It could be as simple as that you want to learn about penetration testing, you want to learn about how hacking works, and you want to set up your own lab. So I'll talk about it. Agenda, as Vandana already started with it, so thank you for that. I introduced the topic already. Before we talk about the VMware Fusion or Workstation, I would like to talk about the foundation, which is what is virtualization itself? Because VMware Fusion and Workstation is actually an aspect of virtualization. So I would like to start there. What is virtualization? Then we'll talk about hypervisor type 1, type 2, because VMware Fusion is a type 2 hypervisor, but I always get asked question, what is type 1 hypervisor? So I would like to talk about that first. And then at the last, obviously, we will continue with our theme of the top topic today, which is VMware Fusion or Workstation. Again, my name is Victor Monga. I am based out of Los Angeles, California. I work for a company called VMware, and it's based out of Palo Alto, California. But I used to travel before COVID up NorCal, but not anymore. So life has been good. I am serving as president for Cloud Security Alliance LA chapter, and I'm also part of a community called Virtually Testing. And I've served as president for ISECA Orange County chapter. I would always appreciate and love to connect with all of you for if you have questions or even just to make professional network on LinkedIn or Twitter. So here are my profiles for LinkedIn and Twitter. Okay, so let's talk about the topic today and the need. Why do we need a home lab with VMware Fusion or Workstation? And as I alluded to it already, either you want to detonate a malware, you want to analyze it, you want to do reverse engineering, you want to learn about penetration testing, vulnerability assessment, or even simple as cyber forensics. I know when I was learning about forensics, I had to deploy autopsy. And Autopsy is a really good tool, but didn't want to install it on my laptop so that even though, let's say, I get a file I want to inspect or assess for forensics, I didn't want to use it on my laptop. So all I did is create a virtual machine, install Autopsy, and did the forensics on files. Now, I get asked these questions again and again. How much or how much money is good enough for a home lab? And my answer usually is it just never ends. I'm not kidding. In past 20 years, I think I've spent more than $100,000 in my home lab, and it just never ends. You just keep spending money. I will say this is what I have gathered with my experience in talking to community people like-minded, such as yourself. What are your goals? So before you even talk about home lab or the money, write down your goals. What exactly are you trying to achieve? Why do you need a home lab? Are you chasing a certificate such as OSCP or maybe some SAN certificate that requires a home lab? What's your budget? So as I said, I may have spent just north of $100,000, but I know people who have spent way more than that, and I know people who spent $10,000 as well in past 20 years. So it literally depends on what's your budget. And at the last is really how much time are you going to dedicate. So I also know some of the people that they spend a lot of money, but they don't even turn on their home lab for at least 30 days or even 40 days. So that's not good enough. You're paying for hardware, licensing, software, and you don't even use it. That's not a good return on investment. So ask yourself these three questions before you think about home lab, before you even talk about what product or solution is good for you. So start there. What are your goals? What is your budget? And how much time are you going to dedicate every day, every week, whatever that means? Now, there are different sizes, obviously. You can do as much as you can go and build an enterprise at your home, or you can start with a simple laptop. So I'll share the slides with Vandana and you can see it. But at the end of the day, it all boils down to how much money you want to spend and what are those use cases. I know I'm running a home lab right now on a server. I have some on laptop. I have some SSDs. You can grow from small to large pretty fast given the money and the budget and the motivation. But I would say start small. Start with something that you can really use it. Return on investment is a key here. You don't want to have so many servers and stuff that you're not even looking at it for months. It's a waste of money and also waste of resources because hardware gets old pretty fast. Before you know, within 3 years, you have to change it. So I would highly encourage. Also with home lab, it's good. I know a lot of my colleagues use cloud for home labs, but I would say it's easier and convenient to have something at your fingertips when you're learning about red teaming, penetration testing, offensive side of the security, because even with cloud, you have so many restrictions that you cannot bypass. So I always love that I have a virtual machine I can spin right then and there and do whatever I got to do, forensics or even reverse engineering or something, and then just delete the virtual machine. It's that simple. Another beautiful thing about virtual machines are you can actually limit the access. So let's say if I have a laptop and I create a virtual machine, if I'm sitting in a Starbucks, I can actually limit my access from virtual machine that it will not be able to communicate to Starbucks network so Starbucks doesn't blacklist me. Or if you're sitting in your corporate environment, so they don't blacklist you. So once again, virtual machines really help me with the red teaming offensive side of the security, and the home lab considerations are always small, medium, large. Once again, go back to those three questions. What is your motivation? How much time you're going to spend? What are the goals? And how much budget you want to spend? Okay, so once again, you can start with as simple as a PC, which has a decent, fairly recent CPU, RAM, storage, and a network interface card. You do need a base operating system. So on your laptop or PC, you need to install Windows or Linux. Or for Mac, it would be Macintosh. And you need ISOs. So I will speak about it, I'll talk about it, the rules, which is you can create a virtual machine, but it's pointless if you don't have an ISO, if you don't have an operating system. And there are four things I will repeat during this presentation: host hardware, host operating system, guest hardware, guest operating system. So this ISO that I have as a third point, Ubuntu, that's for guest operating system. And once again, I'll repeat those again and again, and you'll hear me, which is host hardware, host operating system, guest hardware, guest operating system. All right. With that, let's talk about host operating system. So host operating system is what's actually communicating directly with the host hardware. So literally the first layer, which is imaginary that you can't see, but I have those RAM, hard drive, CPU, and network interface card icons here. But host operating system is what actually communicates directly with the host hardware. And host operating system is generally Macintosh, Linux, or Windows. And that is what is actually communicating with hardware. And that's what we use day to day without even virtualization. So now let's talk about if you do want to use virtualization, you need a hypervisor. That is how virtualization gets done. So you install a type 2 hypervisor, and I will explain the difference between type 1 and type 2. So you actually start with type 2 hypervisor. You will install either VMware Fusion for Macintosh or VMware Workstation for Linux or Windows. So for Linux and Windows, the term is similar, VMware Workstation, but the bits or the installation files are different. Obviously, for Linux, it's a different file, and for Windows, it's a different file. But for Macintosh, they don't use the term workstation. They have a term called Fusion. It used to be Parallels for people who remember that, but now it's Fusion. So once again, host hardware, host operating system, we're good. Then we install Hypervisor to enable virtualization. And then the last two is guest hardware, also known as guest virtual machine. That's where you actually configure virtual CPU, virtual RAM, virtual storage, virtual network interface card, all sorts of virtual things that they interact with physical hardware. So trick question, can I install or can I deploy something higher in guest hardware, which is not available at host hardware? Exactly. The answer is no, right? It's not possible if you don't have, let's say, 16 gig of RAM. If you have 16 gig of RAM on your host hardware, which is your laptop or PC, you cannot create a virtual hardware or guest hardware of 24 gig. It won't work that way. So you always want to make sure that your host hardware has higher resources than your guest hardware. I hope that's making sense, because that's how you're actually going to remember and make sure that the guest virtual machines actually really rely on the hardware. You can't just exceed that number just because you can create it. Okay, on to virtualization. So far we talked about what is the purpose of this home lab and how do we do it and what are the different layers. But let's really step back for a second and let's talk about virtualization. What can be virtualized? And the simple answer is, to be honest with you, literally anything and everything that you have as a hardware. And if your hypervisor supports it, you can virtualize it. It does not prevent you in any shape or form. If you have a hardware, if your hypervisor supports it, you can virtualize it. Simple examples could be on your host, which is your host hardware. You have CPU, RAM, storage, network, obviously. Then you install Hypervisor as an operating system. And your guest at that point is your guest hardware. You can virtualize CPU, RAM, storage, network. So if you see there's a one-to-one correlation in host and guest. Host hardware, I have CPU. Guest hardware, I have CPU in blue. I have RAM, storage, network. Same, I have RAM, storage, network. But the top layer, the blue layer, is actually virtualized. So even though it's a virtual machine, but it does need the resources on the hardware. So once again, you cannot trick or actually go beyond that. You must have host hardware enough resources in order to accommodate on the guest hardware. This is a snapshot from a Type 1 hypervisor VMware ESXi. And I'm alluding here is that you have host hardware, which is CPU. Here we have two CPUs, Intel Xeon. And then you have memory, which is RAM, about 16 gig. And then you have networking and storage. And then you install Hypervisor, which is here in our case is Type 1 VMware ESXi. And so once again, the four things I keep repeating: host hardware, which is CPU, RAM, storage, network. Here you can see it. Then you have host operating system. In our case, it is Type 1 Hypervisor. Then you have guest hardware, which is again virtual CPU, virtual RAM, virtual hard disk, virtual network. And that's what we are showing in the edit settings. If you're looking at that virtual machine as app-01A, it's a virtual machine. And if you actually look at the term virtual hardware, it says virtual hardware, right? So even though the term is hardware and it's virtual, it can be confusing sometimes that why do we call it hardware since it's virtual? Because that is how we actually imagine in our head. So think about it. When we used to build PCs back in, I don't know, 10 years ago or 20 years ago, we used to put CPU, RAM, like every piece, every whatever we need for that PC, we used to assemble it piece by piece. That's how it is, literally. For virtual hardware, you are assembling your PC, but it's a virtual machine at the end of the day. When you install CPU, when you install memory, when you install hard disk, it is a hardware for that PC. And if you think about it, that's what the abstraction is. That's what the cloud abstraction is, because the operating system installed as guest operating system, that operating system doesn't know it's a hardware or a virtual machine. And that's why it's still called a term virtual hardware. All right. So we talked about what can we virtualize, but why do we do it? What's the need? I mean, at the end of the day, it's cool and hip and nice, but what's the use case? Why do we need to do it, right? So I'll give you 10 seconds to think about it. If anyone can come up with good questions or feedback on that one. All right. So why do we need virtualization? And the simple first thing is faults. Back in the days when we used to use physical servers and we used to install database or application or web, or it doesn't matter, you could install all sorts of things. But once the physical server is down, your actual operating system is down as well. So let's say if this was a Windows database server, and if physical server goes down, my database server is down, which is not good, right? I mean, for a company to lose their database server, even though they have multiple, still one could be impactful. And the second is that really you have so much hardware at that point. I mean, these days the chipset and everything has been so much compacted that you can fit so much into a small box. But if you're using one physical server per use case or database, application, web server, you're really wasting a lot of real estate. Next is scalability. So let's say my company is running a web server, public facing, and we have an app server, obviously, as a middleware and database server. And we have three servers: database, application, web server. Database is running about 40% of utilization, app server is running 50%, but web server, where a lot of people are accessing my web server, it's running 90%. So my boss tells me that, hey, Victor, we need to go ahead and install another web server. What's the first step? I need to buy a physical server. I can't just go in and deploy a web server. I need a physical server because that's what we're looking at without virtualization. That's not good, right? I can't scale right away. It prevents me to scale it. So that's where virtualization comes in. Like, what do? I really need to find a way to deploy a web server very fast and even automate it. That's where virtualization comes in as well. Scalability. Now, not only I'm using less physical servers because I can actually scale better, I can actually take an average. I don't need to have all three servers turn on all the time. I can actually move database and app server on one server as a virtual machine. I can run two web servers on second, and I can leave the third one open, either for future or even save the power, right? So that's again a good thing. Why do we need virtualization? First is you can actually use it to prevent the faults. So if first server goes down, you can move those virtual machines automatically to a different host hardware, which is running the same hypervisor. Second is scalability. Now you can actually create virtual machines and deploy those database servers or web servers or application servers on the fly. And that's pretty much the gist of virtualization and an extension cloud. Cloud is all about virtualization and abstraction and automation. Those are the three things in cloud. All right, topic of the day, type 1 versus type 2 hypervisor. So far we talked about, to be honest with you, type 1. That is all we talked about, because type 1 is a commercial level hypervisor where we use to ensure that companies and organizations are safe and you can vMotion stuff, or you can actually ensure the scalability of virtual machines. But as a home user, as a learner, as something who's just curious, I don't have that kind of money and to put on servers and licensing. I just want to have virtualization for my on my laptop or PC, and that's where Type 2 comes in light. So the biggest difference between a Type 1 versus Type 2 is Type 1 hypervisor is actually a host operating system which interacts directly with host hardware. So once again, four things, if you remember it from top to bottom, sorry, bottom to up: host hardware, host operating system, guest hardware, guest operating system. So type 1 is actually a host operating system. Okay. The type 2 is actually which interacts right in the middle of host operating system and guest hardware. That's a complete different. Now, for those of you who understand the interaction of drivers with hardware, you remember back in the days we used to have drivers. We need to install it in order to use in our operating system. So if you need a CD driver for to make CD drive work, or if you install something new hardware, you need to install drivers. So think of it this way: ESXi is a VMware Type 1 hypervisor, which you can use to interact directly with the host. So whatever you install on the host, CPU, RAM, network interface card, graphic card, GPU, solid state drive, whatever that is, it will interact directly. It will actually, you don't need another driver for that. If you install something custom, like from a different vendor, you may need driver for that. You need to load, but anything out of the box, that ESXi can communicate. On the other hand, type 2 is you already have operating system, so you will install VMware Fusion or Workstation to interact with your operating system, so host operating system, and then host operating system will actually communicate with your host machine. All right, let's continue with the theme. Type 1 hypervisor, as I said, there are a lot of vendors out there. Obviously, VMware is one of the popular and well-known brand for Type 1 hypervisor. It's used for commercial use, actually. I've not seen a whole lot of people installing VMware ESXi in their home lab, because for that, you need a server. You can't just install it on your laptop or PC. And then there's also different vendors like Microsoft Hyper-V, Linux KVM, and Citrix Hypervisor. Now, if you think about it, the four things I've been talking about so far, and here are the layers: host hardware, first layer from bottom to up in the gray. Then you have host operating system. Then you have guest hardware, also known as virtual machine. Once again, those two terms are interchangeable because when you create a virtual machine, it's literally you're assembling guest hardware. That's all it is. Without a guest operating system, a virtual machine is useless, a complete useless. If you just create a virtual machine without guest operating system, it's complete useless. It's literally sitting at the BIOS. So once again, four things you always want to remember: host hardware, host operating system, guest hardware, also known as a virtual machine, and a guest operating system. Now, one other thing I've been asked a couple of times, that do I need a separate license for guest operating system if I'm running host operating system as the same? And the answer is yes. For my trial and testing, I use trial version of Windows so that I don't have to pay another license. Linux is my preferred operating system, so it's open source. I never have to worry about licenses. But if you're using Windows or Macintosh, you may want to consider or look into that. So four things. We're going to keep repeating it again and again so that you really get that point where host hardware, host operating system, guest hardware, guest operating system. All right, then let's talk about Type 1 hypervisor. Really look at the layers as we just talked about. So first thing is host hardware. That's what a server is. That's where the real CPU, RAM, network interface card, graphic card, all sorts of hardware is connected. Then second is Type 1 hypervisor. That's also known as host operating system. So just because it's the name Type 1 hypervisor doesn't mean it's not a host operating system. It is a host operating system because you directly install it on the hardware. So anything you install directly on the hardware, it's called host operating system. So it could be Type 1 hypervisor, or it could be Linux, Mac, or Windows. So Type 1 hypervisor is a kind of host operating system. And the reason why we call it Type 1, because it directly interacts with hardware. Type 2 hypervisor directly interacts with host operating system. It could be Windows or Linux or Mac. That is why it's called type 2, because it's a two-step process for that hypervisor to interact with hardware. So first, type 2 hypervisor has to interact with the host operating system. Then host operating system will actually pass that information to host hardware, hence the term type 2. It's not an official definition, to be honest with you. It's just how I understood it. Then the last is guest hardware. That's where the virtual machine you create, you add your physical hardware, as in for virtual machine. So it's a simulation. It's not real physical hardware, but it's a virtual hardware that you are adding to create a virtual machine. You're assembling your machine. So you put your CPU, RAM, network interface card, graphic card, or whatever you have available as host hardware. And that's a key you want to remember. You cannot add something in guest hardware that you do not have in host hardware. They go hand in hand. Okay, let's talk about type 2 hypervisor architecture. Same as always, what we've been talking about so far. First thing is host hardware. You have CPU, RAM, network interface card, and SSD or hard drive platter. Then the second is host operating system. In our case, the first is Mac Catalina, which is Mac OS, obviously for Apple, then Windows, and then Linux. So the point we're trying to make is between host operating system and guest hardware, there is thing called type 2 hypervisor. It needs that in order to enable virtualization. And that is what we use as a home user or a tester or security professional. We actually go through that. So we install VMware Fusion Workstation for Windows or Workstation for Linux. And that is how we are able to create virtual machines, which is a combination of guest hardware and guest operating system. So there are a lot of type 2 hypervisor vendors, and to be honest with you, the only ones I have used in the past is VMware Workstation and Fusion. For obvious reason, I like VMware. That's why I work for them. And second is you have Oracle VMware VirtualBox and Windows VirtualBox as well. They are free, but obviously the features vary. Okay. Now, what are the use cases? Why do we need VMware Workstation and Fusion? One, obvious reasons. You want to create virtual machines for your testing, learning, and maybe some penetration testing exercises. You can also deploy containers or Kubernetes clusters in a single PC if you're using Workstation or Fusion. And who are the people using it? The common use case or the common personas we have seen is cybersecurity professionals or IT developers who wants to test things. And why are they doing it? And it is because they want to have an isolated and secure environment. So even though if they break anything, it's not going to impact your production network. And the last is if you are an admin or if you're using vSphere as well from VMware, you can actually integrate. So the way I use it, I have Fusion on my Mac, I create virtual machines on my local, but at the same time, I also manage my work environment using Fusion so that ESXi and vCenter, I can open it from Fusion. So it just helps me keep everything in the single software and I can manage it from there. This is a screenshot from my Mac operating system laptop, VMware Fusion. I am running professional version 12.1. And the reason why I wanted to put this screenshot here, as you can see, there are virtual machines you can create. You'll see the status. On the left here, you can see the virtual machines and shared virtual machines as well. So at the end of the day, the point is if you want to run any operating system. So on my Mac, I have Windows and Linux at the same time because I can run it within VMware Fusion and test things really fast and quickly when a new use case come towards my mind. There are two versions. Player is the free one. Fusion Pro is obviously the paid one. Pro has a lot more features, but Player is something that you can start today. It's free. You can create virtual machines starting today, and it doesn't prevent you to use that basic features of creating virtual machine. However, if you are interested in Pro, you can go ahead and check it out on the VMware website. This is VMware Workstation from Windows. So Windows, the screenshot looks a little bit different than Fusion, obviously, but the point is creating virtual machine, using virtual machine, it really doesn't matter. Once a virtual machine is created, it looks pretty much the same. Doesn't matter. That's the whole point of abstraction. That's the whole point of illusion, that if I create a Windows virtual machine in Workstation or in Fusion, they both look the same because they're Windows. At the end of the day, I'm using as Windows. So if you are interested, you can learn more about on their website as well. Now, as I alluded in the beginning, that VMware Workstation, this slide is for Linux. So once again, you can install Workstation on your Linux if you're running as a host operating system. And you can create virtual machines such as Windows or Linux. So I have a Linux virtual machines, Linux as host operating system, and I create guest operating system as Windows so I can test things out. So the point is that no matter what's your base host operating system, you can create a guest operating system regardless Windows or Linux. And obviously, with Workstation, you can have Player, which is a free version that you will be able to create virtual machines, but not get the other cool features of Pro, which are snapshots and VMware network customization and all sorts of things. But my point is, if you are ready to take this, you're ready to start with this one, you don't have to wait. You can actually start with the Player and start creating virtual machines. And when you grow in your career and learning, and if you really look at Pro features, and if you feel that that's something you needed, then only invest it. But again, ask those 3 questions before you invest anything. Okay, on to VMware or virtualization networking in VMware Fusion or Workstation. First thing is, there are 3 different concepts of networking. It has nothing to do with virtualization or VMware. It is actually networking concepts. First is network address translation. Think of network address translation as something that's more for hiding your true IP address behind a network address translation. Usually it's a router or a firewall. So let's say if my real IP address is 192.168.1.21, but when I pass it through my NAT router, which is network address translation router, it will change that IP address to something else. So why do we do it? Why do we care for it? So when you do penetration testing, you may want to hide your true identity or the true IP address so you cannot be traced back, I guess. But again, the value prop for this feature is that you want to create a different network for your virtual machines, but you still want access to your physical or host operating system network, so you use NAT. Second is bridge, as the name pretty much says it all. That is, a bridge means whatever your host network, it will just pass it on to your guest network. So if my host is I'm using at my work or home, it will use the same kind of IP addresses, but it obviously different. It'll use the same subnet, but different IP address. So bridge mode is when I need to ensure that if I'm doing something, I can be traced back, then I use bridge. And the last, my favorite, isolated. That means only virtual machines will have access to it. None of the other things like your physical or host network would not have access to it. You will not be able to get to internet. You can only just communicate between the virtual machines. Let's look at it. The first use case, isolated. So here, if you look at the topology, you have internet at the right corner, which is 888. Public IP comes into your modem router, and then we do NAT, network address translation, and then you get, let's say, a subnet of private RFC 1918.192.168.1. Whatever that is /24. These slides are a little bit heavy on the networking, so I apologize for if it's not making sense. Once again, this has nothing to do with virtualization. However, this is how you will use it for your testing, and that's how you'll be able to set up isolated network at your laptop or PC. So going back with the theme here, so let's say your host operating system has an IP address of 192.168.1.11. That could be your Windows or Mac or Linux, doesn't matter. That's the IP you get. But if your type 2 hypervisor, you're using it isolated network, that means there will be a different subnet, and that only they will be able to communicate with each other. So the VM1 on the left and VM2 on the right, they will not be able to communicate to 192.168.1.11. It will block it. Simple. Next is bridge. As I said, as the name says, it literally means it's sharing the IP address from your host. So let's say if your host is 192.168.1 subnet, it's a typo here in this slide. It should be 12 and 13 on the virtual machine. And the last is NAT. Virtual machines have different IPs, and yet they can go to internet by using NAT. So if in the slide, if you're looking at it, there are two places where the NAT is happening. Network address translation is happening. One at type 2 hypervisor, another one at your modem or router. So 192.168.31 address is getting translated to 192.168.1. Then 192.168.1 is getting translated to a public IP to get to internet. So once again, a little bit heavy on the networking, but the point is that you can use these things when you're customizing your test cases. One of my favorite features, snapshots. Why do we care? We care because you can actually create snapshots before breaking your system, before breaking your virtual machine. So let's say if I know I'm going to detonate a malware and I don't know how it's going to react, I'm going to create an initial stage snapshot. I'm going to install something. I'm going to delete something. I'm going to deploy something, and then I will revert it back to initial stage. This is an easy button to go back to where you started if you know that whatever you're doing is going to break something, or if you're not even sure, you can create a snapshot and try it out. If it works, delete the snapshot. As simple as that. We have installation videos on our YouTube channel. I will share with Vandana all the slides and also the links that you can see. It's going to walk you through step by step how to install VMware Workstation for Windows. And the next slide, I have it for VMware Workstation for Linux. And the point is that you'll be able
Victor, the screen is too small.
The YouTube video? The YouTube video is too small?
Yeah, the video. Yeah, I think
Yeah.
the
It's just a slide. It's more for reference. So I'll probably pass on. I'll share the actual links so that it's audience can see it on the YouTube directly.
sure.
Yeah. So once again, the point is that we have recorded it on our YouTube videos, and you can watch it as your leisure. The point is that you'll have it for you. We also talked about the dependencies you need to install it before you're installing VMware Workstation on Linux. Okay, the last topic of the day today, how to create virtual machines using VMware Workstation or Fusion, actually. So it doesn't matter which product you're using, but the process is pretty much the same. As I said, that's the whole beauty of abstraction. So you'll create a virtual machine. There are two options, typical or custom. If you know what you're doing and you have been doing this, you can choose custom and advanced. But if this is your first time, I will highly encourage you to stick with typical, which is the recommended way. The next step you're going to see is where do we install the guest operating system? If you remember back in the days, we used to burn DVD DVD disks so that we can actually install Windows or Linux. Same concept, but now it's virtualized. So you can actually mount the ISO directly onto the virtual hardware or the guest hardware so that when we boot it, it can install that using the ISO. So once again, that's why in the beginning slide I said you should have an ISO handy. Usually I prefer Ubuntu as my beginner learning because Ubuntu, A, it's a free operating system. I don't have to worry about licensing. B, as a security professional, I really need to know Linux. So that's something I challenge myself and learn it. Third screen you're going to see, that's where you're going to select guest operating system. And why do we care for that? Does it change anything? Simple answer is not really. The only reason why you are choosing guest operating system here because it will actually enable you to set up the minimum guest hardware requirements automatically. Simple example. If you choose Microsoft Windows and Windows 10, it will set the virtual CPU, virtual RAM to minimum requirements based for Windows 10. If you set Microsoft Windows, but you choose the Server 2019, it will increase that. If you choose Linux for Ubuntu, it'll decrease that. So based on the preferred operating system, it will help you. But let's say if you chose Linux here, and if you actually installed Windows, it doesn't matter. This is not where you install. This is just a recommended way of VMware Workstation or Fusion to tell you if you choose Windows or Linux, it will actually set those requirements for you. Once again, this is more like a guidance and recommended. It doesn't change anything if you know what you're doing. After that, you will have to choose your disk capacity, which is pretty much is the hard drive. If you think about it, back in the days, we used to buy hard drive. We still buy hard drives, I guess, but that is where you install hard drive. Now, trick question, is it SSD or platter? Is it 15K or 7K? Exactly. The answer is whatever you have it in your host hardware, that is what you're going to consume. So this disk capacity does not dictate SSD or hard drive or 7K or 15K or 10K. This is literally you are carving out a capacity on your host hardware. So if I chose 60 gig from here, and whatever I'm using as host hardware, SSD or HDD, it will carve out 60 gig for me. And the last, you'll see your guest hardware or a virtual machine, in other words, memory, which is RAM, processor, CPU, CD DVD drive, which is pretty much a controller. Then you have network adapter. We talked about 3 different adapters. USB controller. If your computer, obviously the PC or desktop has USB controller, you should actually be able to pass that USB in the virtual machine as well. I mean, think about the beauty here. You can literally pass every single component you have as a hardware inside your virtual machine. It could be USB, sound, uh, GPU, or the display card, or the printer. You can literally pass everything. So as I said in the beginning, you always want to remember what do you have as a host hardware, what does your hypervisor support. So in this case, VMware Workstation is supporting all of those things, and you can map it. You can change these things. So as I said, if you chose, let's say, Windows and you're installing Linux, you can change the requirements. Maybe you don't want that many processors, or you want to increase it. It doesn't stop you. There are different options of virtualization engine. They are a little bit of an advanced level, but the point is, if you are installing virtual machine inside a virtual machine, you may want to look at these engines. Then you also have CD DVD drive. That's where you will mount the ISO. Then you have network adapter. Once again, all of these things, think of you're building your own PC, but now it's a virtual machine, and you will choose it accordingly. Last, there are options, virtual network editor. That's where you will, in Workstation, change settings, such as you can create new network, you can create different type of network, you can create isolated networks, all sorts of things what we talked about, you can do it. And here you will actually see it. So initially, we always talked about type 2 hypervisor has a dependency on your host operating system. And this is a clear example. So if you look at here, in type 2 hypervisor, in our case, VMware Workstation, the name is VMnet1. And on your host operating system, you'll see that name appeared as well. So you'll see the dependency. So whatever you create in type 2 hypervisor, it has to interact with your host operating system. As I said, you can change all sorts of things. You can change your subnet, you can change the DHCP settings, and you can create new networks here. You can change the NAT settings. Once again, this is on the networking side, and if you have those kind of use cases, you should change those things based on your requirements. And if you're doing some penetration testing exercises or offensive side exercises, you should know these settings so that you don't accidentally open yourself for attack from internet as well. So that would be very ironic and I guess not that much funny. But if you're the one actually learning how to hack, and if you get hacked on your virtual machine, it's not going to be good. So know these settings up front. Make sure that you understand how your virtual machine is created. If it has internet access, you may want to block it before you actually do the offensive exercises. And as again, story goes on, you can add more networks. If you add it, it will show up in the virtual network editor. It will also show up in your guest operating system and host operating system, and you can change it here. These are different settings. As I said, you can have USB, sound card, display, printer, whatever you have on your host operating system or host hardware, I should say, that a type 2 hypervisor can support, you can see it. This is one thing I am very close, and it's near and dear to my heart since I have networking background. I am creating another talk or workshop where we will actually tweak the network adapter settings to simulate a real world scenario. So let's say if you have a workshop, or not even workshop, if you have a use case where the packet loss can only be tolerated for 20% or latency can be only 3 milliseconds, how do you test it? Because right now, there is no way for me to add that kind of latency in virtual machine manually. But using these adapter settings, I can actually add it and really see using either iPerf or doc to how my application reacts. So if you build an application, if your company have an application that they want you to test it with the different latency and packet loss, this is where you will change it. And I will have another talk and workshop, and I'll talk to Vandana if you are interested as well. The last slide, I promise. This is where we talk about the depth, breadth, and length of virtualization. I really wanted to show this because this shows the true value of virtualization. So if I only have one physical server on the left to right, so if you start looking at from left to right, physical server 1, I install ESXi, which is a type 1 hypervisor. I create a guest virtual machine as ESXi as well. And yes, you can do that. It's not supported, but yes, you can do it for testing. Then install guest Windows on that guest virtual machine ESXi. Then I install type 2 hypervisor, which is VMware Workstation. And the last, I create guest virtual machine. So if I am sitting right here for this virtual machine, it has no idea about the depths, like how many steps, what are the abstraction, and that's the crux of cloud. When we create one EC2 instance, it is something like this, but you don't know the layers it's passing through. And that's it. That's all I have on that. We'll take some questions now if anyone has any questions for me.
Th- Thank you so much, Victor, for the wonderful session. I am sure
Absolutely.
it's going to help really, really to the people who are kickstarting their career in the testing.
That's awesome. Yeah. Are there any questions, Vandana? Anyone has any questions for me?
I was just actually looking at that only. I don't see any question, but I would say that if you can send me your email address, like I can see it here. I'm going to post it there in the channel also,
Okay.
where actually they're going to reach out to you.
Okay. Sounds good to me.
Yeah, because what happens is a lot of times that some they are not on the stream, but they go back and check, and then they have a lot of questions.
Okay.
So yeah, that's majorly happens. So we always make sure that we check with the speaker that if they can share their email address or the contact details.
Sounds good. Perfect. Thank you.
Thank you. And also, everyone, do check out his YouTube channel and virtuallytesting.com. They keep posting incredible videos around cybersecurity and, in general, virtualization or anything around technology.
Awesome. Thanks so much. Thanks, Vandana.
Thank
Take care.
you. You too. Thanks, everyone, for joining us today. Take care.